In this video, we will discuss the problem insert intervals. Let's read the problem statement and understand what we have to do in this problem. Problem says that Geek has been given an array of non-overlapping intervals. So all the intervals that are present already in the array, they are not overlapping. For a particular interval, we'll be having the starting and the ending of the interval given. Now the question says that the intervals have been sorted in the ascending order of the starting time. Okay. Now Geek wants to do what? Geek wants to add a new interval where the starting and the ending represents the start and the end of the new interval here. So you will be given a single array which will be consisting of a new start and the new end. The new interval that we want to insert, we will be having the starting and the ending for it. Now we have to help the Geek to insert the new interval into the existing interval such that the interval is still sorted in the ascending order by the starting time and there is no overlapping interval. So suppose that if we are pushing this new interval inside the existing intervals, then after this we should process the input data in such a way that finally the overall all the intervals do not overlap with each other and they are sorted according to the starting time. So let's consider the first test case here. Suppose that if we have got something like this. Suppose that we have got 1 3, then we have got what? Let's say we have got 4 5 after that, and then we have got 6 7, and then after that we have got what? 8 and 10 also. Suppose we have got this particular data here and we have to insert which interval? We have to insert the interval 5 comma 6 here. So this is the extra interval that we need to insert. Now if you will see here, what will happen? 1 comma 3 does not overlap already, so 1 comma 3 can be written. Then after that you can see 4 comma 5. Now if you observe carefully, so 4 comma 5, 6 comma 7 and 5 comma 6, these three are overlapping. So what will happen, instead of these three intervals, we'll write one interval that is from 4, starting from 4, because the smallest start time is 4 and the highest ending time, the maximum ending time is 7. So we can write 4 comma 7 here, and then at the last you will write 8 comma 10 here, like this. So this is the final merged intervals that you will have, and basically instead of these two existing intervals that were overlapping, and with the new interval we have put the interval 4 comma 7 here. That is what we have here. But how will we do in terms of application, in terms of implementation? How are we going to do this? So the approach is very simple. One approach is a very brute force approach which we can apply, which is basically related to the concept of merging the overlapping intervals. And the next approach that we can think of is basically the approach where we can apply a little more logic and do it in linear time. So let's quickly discuss the basic brute force and the naive approach for it. So what we can do is, we can basically say that whatever intervals we already had, whatever intervals we had been already given, suppose that these were the intervals that we were already given, we can do what? We can say that we will insert this new interval into that list as well. So what will happen is, it's like we'll insert 5 comma 6 at the end of this particular existing list. Now once I do that, then I'll sort again. I'll sort this particular interval list again in terms of the starting time. Now what will I get here? When I'll sort it, I'll get basically 1 comma 3. Then after that I'll get what? I'll get 4 comma 5. Then I'll get what? I'll get 5 comma 6 here. Then I'll get what? I'll get 6 comma 7 after that. And then I'll get what? I'll get 8 comma 10. So this is what I'm going to get here. Now after this, what we will do is, we already had the data intervals of the intervals. Now after this, we have inserted this new interval and we have arranged the data in the sorted format of the starting time. Now once this is done, we'll still iterate, and now the problem is related to merging the overlapping intervals, because we just have to merge the overlapping intervals. So it's like we can take a resultant array here, and basically initially we can say that the interval will be 1 comma 3 that we can directly put in this result, and we'll always check the current interval with the last interval merged. Okay, so current interval is basically which interval? Like 4 comma 5, and we'll check it with 1 comma 3. Do they overlap? Right now they are not overlapping, so we will basically put the current interval in the resultant list. So 4 comma 5 is going to be put here. Now after this, what will happen? Next up, we'll move to this particular current guy. Now what will happen here is, now we'll be at this particular interval, that is 5 comma 6 currently, and the last merge interval is 4 comma 5. Is there a overlap between the last merge interval, that is 4 comma 5, and the current interval 5 comma 6? Yes, because the ending is 5 and the starting is 5 also, so there is an overlap because they are equal, so there is an overlap. So then in that case, I'll say that I'll update the ending of the last merged interval with the maximum of the ending of the last merge interval and the current interval. So the maximum is 6 here. So I'll update it with what? 6. So here we can do what? Here we can update this with 6. Now after this we'll move forward, and my current will be starting at the next interval, that is 6 comma 7. Now current interval is 6 comma 7 and the last merge interval is 4 comma 6 here. Now do they overlap? Yes, they do overlap. If they overlap, so I'll update the ending of the last merged interval with the maximum of the ending of the current interval and the last merged. So the value maximum is 7. So this will be updated with 7. So you can indirectly see that for all these three intervals, we have generated a new interval 4 comma 7 here in the resultant list. Okay. Now what will happen? We'll move forward and we'll be at the last interval here. Now we are at 8 comma 10. So currently we are at 8 comma 10. Does it overlap with the existing last merged interval in the result? No, it doesn't. So since it doesn't, so I'll directly put it in my answer, and 8 comma 10 will behave as the last or the latest merged interval. Now after this we don't have anything, so this is what we have got. You can see that the expected answer was also 1 comma 3, 4 comma 7 and 8 comma 10, and we have got that also. Now basically what did we apply here? We applied a basic simple approach that initially whatever new interval that is there, we'll put it in the interval list. Okay, and then we'll solve the data according to the starting time, and we'll apply the logic of merging the overlapping intervals, because after putting the new interval in the existing interval list, some of the intervals might overlap, so we have to merge those overlaps. Now if you see, time complexity for my code is going to be order of n log n, because I'm applying sorting here. That is the maximum complexity that I'm paying for. And if you see the space complexity for my code, it is going to be what? It is going to be order of n here. Why? Because I'm generating one final answer resultant list here. Let's try and have a look at the code as well. So yeah, let's have a look at this code. So if you see the code here, what we are doing first of all is whatever new interval has been given to us, we are first of all adding it to the list of the intervals that we already had, and then we are calling our merge overlap function here. Now what we are doing is initially we are inserting the intervals on the basis of the starting time, when we will say that the initial result will contain the first interval in the list. Then after this, we'll iterate. And what we are going to do is we are going to access the last interval, last merged interval from the resultant list that we have created. And then what we are going to do is we are going to iterate. And currently we'll be at the ith interval. Now, if the ith interval has a starting which is lesser than equal to the ending of the last merged interval, then there is an overlap. And if there is an overlap, then we'll update the ending of the last merged interval with the maximum of the last merge interval ending, comma the current ending. That is what we were doing already. But if the last merge interval and the current interval, they do not overlap, then we can directly put the current interval in the resultant list, and that will be treated now as the new last merged interval. At the end of the day, we'll just return the resultant list, which will contain the final merged list. Now this takes order of n log n time complexity, because we are sorting according to the starting time, and it takes order of n space complexity, because we are creating a new resultant list. Can we do something better? Can we do it more cleverly? Yes, we can do it more cleverly. How? So let's see what we can do here. Basically, the expected approach is that we can do it in order of n time. Now you'll say that how we can do it in order of n time. So the basic intuition is that whatever new interval you have, got, suppose that you have got this particular new interval. If you have got this new interval, the thing is that there will be some intervals before it that will be non-overlapping in nature. Some intervals will be before this interval that will be non-overlapping, and some intervals will be at the end that will be non-overlapping. Some intervals in the beginning will be non-overlapping. Some intervals at the end will be non-overlapping. So I don't need to take care of them. Some intervals will be there in between that will be overlapping, and I just need to consider the merger for that part. So what I can do is, in my resultant list, I can initially try to iterate, and I'll try to put all the initial intervals, starting intervals that are not overlapping with the new interval that I'm planning to insert. So I'll add them in my result. And then after that, once I see that the intervals have started, which are overlapping with the new interval that I want to insert, then I'll basically try to process one interval only that will take care of the overlapping intervals. So then I'll add this single interval for that. And then after that, once we are done with this, then whatever intervals are there at the end, which are not overlapping, we'll write them in the result. So this is how it is going to simplify the approach here. So let's try and see a dry run for this using the sample test cases here. So suppose that if we have been given this particular test case, that is basically firstly we have been given what 1 comma 3 has been given to us, then we have been given what 4 comma 5, okay, then we have been given 6 comma 7 here, and then we have been given what 8 comma 10 has been given, and then after that we have been given the interval that we want to insert is 5 comma 6. Now initially you will create a resultant list. You will check, does 1 comma 3 interval overlap with the new interval? No, so we'll directly add it in our answer. So 1 comma 3 is added. Now next time I'll be at which interval? Next time my current interval is 4 comma 5. Does it overlap? Does it overlap with the new interval that I want to insert? This is the new interval that I want to insert. Does it overlap? Yes, it does overlap. So if it overlaps, then I'll see that what is the starting point that I can consider. If you see, so initially, I can say that my starting point would be the minimum. So starting point here is basically 4, and the end point I'll try to keep it as maximum. So out of 5 and 6, the maximum would be 6 here. Now after this, I'll go forward to the next interval, and now I'll be at this particular interval, that is 6 comma 7 here. Now I'll check, the starting will be still 4, but this interval is also overlapping with the existing interval, because the end time here is 6 and the end time starting time here is 6, so there's an overlap. So now the end time would be updated to what? 7 here. The maximum would be 7, so it would be updated to 7. Now when we go to the next interval here, does it overlap with 4 and 7? 4 as the starting, 7 as the ending? No. So we can say that now the interval, that is 4 comma 7, it represents the overlapping intervals of in one single entry. So we can put it in our result, and then we'll iterate further for all the rest of the intervals after this which are there, and we'll put them inside. So we'll put 8 comma 10 inside because it is not overlapping. So as I said, there would be some intervals in the beginning which are non-overlapping in nature. There will be some intervals in the beginning which are non-overlapping in nature. Okay, so we'll put them. Then whatever overlaps are there, for that we'll put one single interval. Okay, we'll process them and we'll put one single interval, and then at the end, whichever intervals are there at the end which do not overlap, we can directly write them. So it's just a simple approach that we have applied. So this way we can linearly iterate, because we are using the fact that already the intervals that have been given to us, they are sorted in the ascending order. So this is how we can do it in linear time, because the time complexity here would be just order of n. We are seeing we are just iterating throughout all the intervals normally, and the space complexity would be order of n also, if you consider the resultant list that we are creating here, because we are returning the final result of merged intervals. So let's quickly see the code for this as well. If you will see the code here, firstly what we have done is we have created a resultant array here, a resultant list that we want to return for the merged intervals finally after inserting the new interval. Then initially we are starting our I from 0. We are taking the length of the intervals. Then initially we are the first while loop that we are running, we are basically adding all the beginning intervals that are not overlapping with the new interval that we want to merge. So for this we are taking care of the condition that if the ending of the intervals, if it is basically less than the starting of the new interval, then we can safely say that there is no overlap, and let's put all these intervals that are there at the beginning and they are not overlapping with the new interval in the resultant list, and keep on increasing our I. Now after that you will have to do what? You have to process the intervals that are overlapping. So once you come across those intervals, once you come across that index from where the from where the interval is overlapping with the new interval that you want to insert, so then we will do what? Then we'll say that the start. So then we'll say that the start would always be the minimum of the start interval that I want to insert, comma the current ith interval that I'm at, and we'll try to keep the ending as maximum possible. Because suppose that if I have got 4 comma 7 here, and I have got what 5 comma 8 here. So the thing is that the starting should be, if these intervals are overlapping, so the starting should be minimum possible. So starting would be 4 here, and the ending should be maximum possible, so it would be 8. That is how I'll be able to cater this whole overlapping interval in one single interval. Okay, so that is why we are taking the starting as the minimum and the ending as the maximum. Now once my merged interval is ready, once my single interval is ready, which is representing all the overlapping intervals in one single new interval, then I'll basically put it in the resultant list. Then after that, at the end, you have those intervals which are not overlapping, so you'll directly them as well inside the list. Wherever your index I is there, you'll just keep on iterating and you'll insert all those elements as well, all those intervals as well. So this would take order of n time complexity and order of one space complex, order of n time as well as order of n space complexity. Let's now try and submit this code as well. So you can see it's working fine on the samples. And yes, this code got accepted. So let's submit this code now. So you can see that the code is passing on. You can see that the code is passing on all the test cases. I hope you have understood this. Thank you for watching this video.